Hello and welcome everyone to Building Materials and Testing. This is our first lecture. We had this lecture in the first week of semester before we all had to go home because of the coronavirus quarantine. I'm recording it just as a test and also just for your own revision. But this is an introduction. I do recommend you still listen to this even if you were there for the first lecture, because some of the details about the course have changed because we've had to have quarantine because of the lockdown and coronavirus. This is now a shortened semester. It's a 10-week semester, and I need you to be aware that the assessment for this module has changed somewhat. So I want to welcome everyone here. As I said, this is the Civil Engineering 201 Building Materials and Testing module. It's a module for UG1 students in the Civil Engineering program at the University of Kurdistan. Now, this module has changed considerably from the start of semester because of the coronavirus pandemic. From now on, we will be doing online study for the time being until such time as we can go back to the campus. So a couple of key things you need to know. First off, there will be lectures, and these will be lectures that will be pre-recorded videos, and there will be 2 videos every week. Each video will be about 1 hour in length, and you can watch these in your own time. There's no set requirement that you need to follow the timetable that you received from the registry at the beginning of the semester. So watch these lectures in your own time and also take notes. Now, at 10:30 a.m. on Thursdays, now that is the final lecture slot that we had initially with from registry when we were still meeting on site. We're going to have an online tutorial. That means that we're all going to log on via Zoom. If you're not familiar with Zoom meetings, find out about it. It's a fantastic piece of technology. And I've sent you a link on Moodle for how to download it. The link for the meetings will also be on Moodle, and it will give us a chance to talk for an hour or so, and this will mean that we can talk about the lecture material. If there's anything you don't understand, I can explain it to you. I'll have a whiteboard with me so I can explain it a little bit more in depth, and I will also be able to help you maybe with your assignments. So that's a good reason to log on to the tutorial. Now, I realize that we live in Kurdistan and internet is always a little bit hit and miss. Now, I want you to know that if you can't come on to the tutorial at 10:30 on Thursdays, don't worry. I can still be contacted during office hours, so 8 a.m. to 4 p.m., Sunday to Thursday. You can contact me on my phone number or on my university email. Both of those contact details are available on Moodle. I'm going to be doing all my communication to you via Moodle, so if you haven't logged into Moodle already, remember the name of the module is Building Materials and Testing, and the enrollment key is John 1125. That's with a capital J. And so, yeah, that's just a reference to John chapter 11, verse 25, which is one of my favorite verses in the Bible. Now, you're going to be expected to do about 3 hours of personal study a week. This is in addition to the lectures and the tutorials. So this will be spent writing notes and also doing the assignments, and there will be an assignment every week. Now, assessment. This is something that has changed significantly because of the coronavirus pandemic. Now, before the coronavirus pandemic, you had 13 weeks of teaching in the semester. Now you only have 10. Also, there is no midterm exam anymore. So, you will have an assignment every week which you will be able to do if you follow the lectures, and if there's anything you don't understand, discuss it with me via the tutorial or contact me. There will be an assessment every week. There will be 8 of them in total. They are worth 50% of your final grade. The final exam will be in week 11. Remember, it's a shortened semester now. There's only 10 weeks of instruction, so that will be 50% as well. Now, I will say that I say it's a 10-week 10 weeks of instruction now with this semester. What you need to know is that we've already done 1 week. We had the first week at the university. If you didn't turn up for those assignments, you need for those lectures, you need to catch up in your own time. Now the final book exam is open book. Now, if we are able to go back on campus before the end of the semester, then we're going to be conducting the exam as we normally would at the university. There will be an invigilated exam on the 3rd floor, and I will let you take in any handwritten notes into the exam. This is a huge incentive for you to write notes. I want to encourage you to write notes. You cannot take printed notes into the exam. Now, there is a small chance that this pandemic quarantine is going to continue to the end of the semester. Now, should that happen, we will need to do the exam online, and I'll probably do it through Moodle using Moodle quizzes. It will basically just be a long quiz. And obviously, I can't invigilate you. And so if that were the case, you can use printed notes because you'll be on your laptops anyway. So let's look at this class example here. Look at this house, and I want you to ask yourself 3 questions. What materials were used to make this building? What were the materials used for, their purpose? And why was that material chosen? So we can see a few different materials here, can't we? We can see aggregate for this path. We can see stone being used here for the retaining wall. We've got a brick masonry wall here. We've got a wooden wall here. We've got a steel roof. And I think we have glass windows, obviously. And I think the joinery, the slots that the glass fit in, I think that's probably made from aluminium. So why did we choose different materials for different purposes? Well, some of them are obvious. What material would we use for glass? Well, a property for the window, sorry. Well, obviously, the material needs to be see-through. It needs to be transparent. The purpose of a window is so you can look through it. So you're not going to use concrete, for example, to build your windows. There's really only 2 materials you can realistically use, glass or perspex plastic. Or why down here is this path made from aggregate? Well, you could say, why didn't they use concrete here? Well, one of the properties of concrete is it is actually quite expensive in comparison to aggregate. So unless you needed a property that only concrete could give you, you're probably going to use aggregate. What about these walls here? They're made from wood. Why are they not made from concrete? Well, look at this design here. This is actually flexing in this direction. Now, concrete has really good compressive strength. That means you can squeeze it and it can withhold a really big force. But equally, concrete is very weak in tensile strength and flexural strength. That means if I had a brick of concrete and I had a clamp on either end, I could pull the brick apart. I could stretch it and it would crack very quickly. So they needed a material here where you've got this cantilever where it's leaning over on a big beam. They needed a material that had good tensile strength, and that's why they used wood. If they had used concrete, it would have broken. And with every material that's used throughout the house, there is a reason why they chose that material. The properties of that material matched the requirements of that component of the building. So that's what building materials and testing. We've got another example here of a really beautiful cable stay bridge. So what materials were used for making the bridge? What were the materials used for? Why was that material chosen for that component? Well, we've got a few different materials here, if you can follow my cursor. We've got this big column where, what do we have with the column? We have with the column, probably it's reinforced concrete. Now, that's under compressive load, isn't it? The cables are pulling down onto the column and the ground is pushing up, so that column is being squeezed. Compressive force. Now, as I said in the last slide, with concrete, it's got great compressive strength, and that's why they chose it. But look at those cables. What would happen if those cables were made from concrete? Well, what are they under compressive load? No, they're not. They're under tensile load. Those cables are being stretched. They're being pulled. Now, if they were made of concrete, they would snap and crack almost instantly the moment a truck drove over the bridge, because concrete, although it's very strong in compressive strength, it's weak in tensile strength. So those cables were most likely made from steel, which has very good tensile strength. Now, with the course curriculum, we're going to be looking at different materials which are used throughout civil engineering projects, and we're going to be looking at the properties of those materials. So those could be mechanical properties, forces and strengths. They could be chemical properties or physical properties, what it looks like. And we're going to also be talking about how to test these properties for these different materials. So that's why it's called building materials and testing. So materials that we will be covering in this lecture will be first and foremost aggregate. This is one of the most basic and most common materials we use in engineering. It's basically particles of rock or soil all mixed together. So you can see there's a picture of a quarry, which is, I'm sorry, I don't know the term in Kurdish, but in Arabic it's mahjar. So a place where they break rock out of the ground and then they crush it into different sizes. That's aggregate. We're then going to talk about cement. Now, cement is just a word meaning glue. From Latin, cementia, it means glue. It basically can be used to stick things together. So concrete is basically aggregate that has been glued together with cement. So with cement and with aggregate, we would then go into concrete. Now concrete is so common. We have concrete in almost every building, every civil engineering project in the world. And it is so important that we're not actually going to be covering concrete in any depth in this building materials and testing module. The reason for that is because we have a shortened semester but also we're going to talk more in depth about concrete when we do concrete technology, which is a UG2 module. In addition to the UG2 module, concrete technology, we'll look at reinforced concrete, and we will also look at special kinds of concrete. Concrete is a really big subject. It deserves its own module. You could easily do your 4th year project or your 5th year, your master's, or you could do a PhD. I've had colleagues who specialize in concrete research. It's a field unto its own. So it's a big subject and it deserves its own module. So we're not covering that in building materials and testing this semester. We're going to look at grouts and mortars. What are grouts and mortars? They are basically very viscous concretes which are used for sticking masonry blocks together, or bricks. So you can see there a man making a brick wall, and that grey stuff is mortar. It's a type of concrete used to stick the masonry blocks together. Glass and ceramic, I don't know if we're going to cover that, in all honesty. It's becoming a bigger part of civil engineering, but we may not have time for that, unfortunately. We're going to look at masonry, so you may have heard me use that term. Masonry is basically a word used for block structures. So you can see that man there. He's making a masonry wall. He's using concrete masonry blocks and he's arranging them in the shape of a wall. And obviously they're stuck together with that special concrete called mortar. We're going to look at a few different kinds of masonry, and one of the key ones I want to talk to you about is clay masonry. This is masonry where the block is not made from concrete. It's not made from heated earth. Instead, it's just made from clay that has been compressed. It's an area of research of mine, and I think it has a lot of potential in Kurdistan. If you go to the old bazaar area, all of the old houses down by the citadel and the bazaar, they are made from adobe or clay masonry. I want to talk about that for maybe half a lecture because it's a very interesting material. We're then going to go into timber. So timber is the engineer's term for wood. And so we're going to talk about wood, some of the good properties of wood, the different kinds of wood that are available, and how we can use them in civil engineering. Asphalt is the black stuff you see on a road. So asphalt is a mixture of aggregate and bitumen. It's very similar to concrete. Concrete, as I said, is aggregate which is stuck together with cement. Asphalt, on the other hand, is aggregate which is stuck together with bitumen. And bitumen is that thick black tar stuff that comes out of the ground. It's one of the low quality petroleum products, and you have a lot of that here in Kurdistan. So we're going to talk about asphalt. We're going to talk about why we use it on roads, for example, and also other applications for it. Finally, we're going to be talking about steel and aluminium. There's a few different kinds of steel, and we're going to talk about the different grades, the different properties, and how we can use that for different components in civil engineering. So testing covered, as I said, it's building materials and testing. Now, you may remember that I told you at the beginning of the semester there would be laboratories where we would be testing things in the lab. That's going to be pretty problematic for us with the pandemic. We're having to do online learning by distance. If we do get back to the campus, before the end of semester, we will be doing all of the labs in bulk, and we'll look at doing that. But for now, you need to know that the labs are not being assessed. There's no marks associated with the labs, and if we do not get an opportunity to do these tests before the end of semester, we will give you another opportunity through your course to do these tests. So there's a whole bunch of terms. You're going to be learning about what each of those mean and how we test for them. So this is one test called a grading test. This is in the lab. Now that machine there vibrates, it shakes. And what you do, where you see that plate which is grey in colour, you place a series of sieves of different sizes on top. You can see one of the sieves there. And what this does is you place an aggregate sample in the top sieve, and it shakes, and all of the smaller aggregate falls through the sieve. And basically you can determine the different proportions of the different sizes of aggregate. That'll become clearer in time. Shear testing, this is basically testing material to see how well it tears. Flexural testing, this is for testing beams. So you can see there's two props at the bottom that would hold up either end of a beam, and then there's a hydraulic ram that pushes down in the middle of the beam, and we're trying to see if it breaks or at what strength it will break, what force is required to make it break. Tensile testing, that's where we're stretching a material, and this is good fun. You can see in the middle there's actually a steel sample which is being stretched, and the hydraulic rams on this are really strong. So as it's being stretched, it will actually pull and stretch out like chewing gum or bubble gum. It's really quite cool to see. Compression testing, that's a great fun test too, and you will get an opportunity to do this. This is a concrete sample there which is being squeezed, and we're seeing how strong it is. We're seeing what force is required in order for it to crack and break. So we're also going to look at temperature susceptibility, although there isn't a test associated with that, but you should know that some materials, they get their properties change with temperature. For example, did you realize that if you had a concrete which is exactly the same, it will be stronger in Erbil than it will be in Saran? The reason is because Saran is colder, and the cold actually makes the concrete weaker, just ever so slightly, but you've got to account for that in your design. The Los Angeles test, boy, this is a really fun test, and we will get an opportunity to do this in time. But this is basically testing how hard a material is. So you don't need to understand exactly how that works right now, but that's just an overview. Now, everything that I have shared with you so far, there's probably a lot of terms you don't know. You probably don't know what flexural strength is. You don't know what hardness is. You have no idea what grading is or the Los Angeles test. Don't worry, I've just given you an overview just now of everything that you will learn in the coming 9 weeks. But right now I want to begin with giving you a historical perspective on building materials, and this is pertinent for what you need to know for your first assignment. So your first assignment is available on Moodle now, and that's due on May the 10th. Please make sure you do that assignment. So, during the Stone Age, when was that? That was around 6,000 years ago. People used different rock materials for different purposes, based off their properties. So these were very primitive people. They didn't have any fiberglass, they didn't have minerals. All they could use for materials was basically wood, straw, and stone, and that's why it's called the Stone Age. So, how did they choose what material to use for what purpose? Well, even though they only had stones and maybe a couple of other materials, they realized there were different kinds of stones which had different properties. So look at this stone here. This is obsidian. So it's a volcanic rock that comes out of volcanoes. It's very black and glassy. You don't have a lot of this in Kurdistan, but I do hope you get to see this in time when you do Introduction to Geology. Now, one of the things with this material, obsidian, is it's not very strong. It breaks very quickly. If you put any force on it, it will crack and snap very quickly. However, it's really hard. Now that means it's very hard to scratch, and you can actually make it really sharp. It doesn't go blunt. And that's why the Stone Age people, they used obsidian for spear tips. That picture there is actually a spear tip which was found in Kurdistan, and they believe it's probably about 6,000 years old. Now, look at this instrument here. This is actually a hammer that was 6,000 years old or so. They only found the rock. But basically, they needed something that was very strong, and they needed something that was very heavy too for the hammerhead. And so what they have used here is they've used granite, which is a type of metamorphic rock. You don't need to know what a metamorphic rock is for building materials and testing, but you're going to learn what that is in Introduction to Geology. So granite makes a very good material for hammerheads. Now, one of the bad things about granite is it's very strong and very dense, and that means it's very hard to shape. You can't chisel a new shape out of the granite, unless of course you have special machinery, which the Stone Age people didn't have. So whatever stone you picked up, the shape of that stone would have to do. You couldn't break it into a new shape, so you could never use it for a spear tip like you could with obsidian, for example. But of course, for an object like a hammerhead, all you need is really one flat surface, so it's quite easy to find a suitable rock when it's granite. Now, after the Stone Age, we move into what's called the Bronze Age. Now, this is around the era of 4000 BC, so this is between the time of the prophet Moses and King David. Now, what happened was that often the Stone Age people, they would have stones placed around their campfires, and they noticed that sometimes around these campfires, when stones got really hot, they noticed this metal ore or this golden liquid melting out of the rock. And what they were discovering was metal. And in that time, they discovered two different metals. Now, they first discovered copper. There were some rocks that had copper ore in them. Now, copper was very, very strong. It's got good strength. The trouble with copper is it's also very soft. You can scratch it and bend it really easily. Now, there was another material called tin. This was another metal. They would find other rocks that had tin ore, and they found that tin was very weak. It couldn't withhold a big force. You could break it quite easily. It crumbled, but it was very hard. They could make a real sharp object out of it. They couldn't scratch it, and it could actually scratch other objects. Now, what would happen? It didn't take long for human history for men to start going to war with one another, and so there was a big need for weapons. Now, if you are making a weapon like a spearhead or a sword or a shield, you need the material to be both hard, so it doesn't bend, or it doesn't scratch, or it doesn't crack, but you also need it to be very strong, so it can hold a big force. Now, what they discovered in the Bronze Age was if they got these two metals, tin and copper, and they mixed them together, they would produce an alloy. An alloy is basically it's basically a hybrid metal. Word in Arabic would be hajin. It's a mixed metal. And the metal that was an alloy that they were using was bronze. It was a mixture of tin and copper. And they were able to make spearheads and shields and all sorts of weapons, far better than the obsidian spearhead you saw before. They were also able to make plows. You can see a picture of a man there plowing the ground. And it really advanced agriculture because of that. And also in this time, they also discovered silver and gold. And before long, those materials became a currency. They were using it for money. But as I say, this was sort of between the era of the prophet Moses and King David. And many of you may know the story that King David killed a giant by the name of Goliath, or in Arabic, Jaliot. And this giant, according to the Bible, he actually had a bronze helmet because it was the Bronze Age. And you can see there a picture of a man making an axe head, where he's basically mixing two ores together and making an alloy which is bronze. He's mixing tin, and he's also mixing copper together to make bronze. Now, after the Iron Age, after the Bronze Age, we have what's called the Iron Age. Now, the big issue with bronze is that most places do not have copper. They do not have tin. Those are rare metals. And so the only places where they really had copper and tin were places like Kurdistan, Egypt, and also China. And that's where civilization really took off during the Bronze Age. That's why Kurdistan, or Balad al-Rafidin, or Syria, is sometimes called the cradle of civilization. Now, iron, on the other hand, is a metal which is found all over the world. So anyone could make iron. It's available. Now, it only exists in nature as iron ore. You're never going to find pure iron anywhere in nature. It's always going to be iron ore, which is iron mixed with oxygen. Now, the reason why no one had used iron up to this point was that iron has a very high melting point. It's very high. It's around, from memory, I think it's about 1,500 degrees Celsius. So there's no way you're going to get a fireplace that hot. However, they realized in time that if they actually had a fireplace, a campfire, in a cave that was right at the back of the cave where there wasn't much oxygen, basically this new kind of metal would melt out of the rock. Now what was happening was that if they didn't have a lot of oxygen in the atmosphere, the fire would take oxygen out of the iron oxide. So, and then the iron would basically replace that oxygen atom with a carbon atom. And that's where we get steel. Steel is a mixture of iron with carbon. It's an alloy, it's a mixed metal. Now, it didn't really melt out of the rock. It basically just turned the rock into a soft, spongy material. And so they could then take that soft, spongy material and they could bang it into a shape. This is called smelting. And you can see a picture of that there. In the top left, that man is smelting iron. And it depends whether one of the interesting things with steel is the higher the carbon content, the sharper the steel is. But the higher the iron content, the stronger the steel is. And so there was a trade-off. And so we're going to talk a bit more about that when we do steel at the end of semester. Now, what you need to understand here is we've gone from the Stone Age to the Bronze Age to the Iron Age to now. Many people, many historians would say that the last 2,000 years we should really be calling this the Concrete Age because we use concrete in abundance. But what I'm trying to show here is that the material that was most predominantly used in that age defined the age. And throughout history, the discovery of materials and the utility of materials drives civilization to newer and better things. Now, the materials were always chosen through history based on availability and manufacturing technique. So was the material available and could they manufacture it into the components they need? And the same two principles apply today. So just an example, the Sumerians, they were an ancient people group that were basically found around Tikrit and Salahuddin and Mosul, around that area. They used to use bitumen as mortar. So you can see that picture there, a really old masonry house, and the mortar is this black tar. Why did they use bitumen and not cement? Well, because bitumen was really useful. It was very available. They didn't have cement. Well, they did have cement, but they didn't know how to manufacture it back then. It was available. It also had a lot of other good properties. It's really sticky, so it's a good adhesive. It glues the bricks together. And it's also waterproof, so rain is not going to come through the wall. Now, one of the big issues with bitumen is that it's not available everywhere. That's why the Middle East gets a lot of money for oil. If every country could produce its own oil, there would be no reason to trade with the Middle East in many ways. So they couldn't use this material in other places. Another drawback is that bitumen deforms with heat. And of course, Iraq is a very hot place, and that's why in time, when the Sumerians discovered cement, they started using that instead of bitumen, because it actually made a better mortar. Now let's go forward in time to the discovery of cement. Now, the Romans existed around 2,000 years ago, and they started using concrete around 145 BC, so about 150 years before Christ. Now, cement had actually been discovered long before the Romans. The Egyptians had used it, but basically it wasn't very available. There was a little bit of concrete work happening, but it was only really until around 2,000 years ago cement started being used in a big way. So the cement that they used was a cement called calcium carbonate, or another term for that is lime. So lime is basically calcium carbonate, and they discovered this from crushed seashells. So the Roman Empire stretched all over Europe and North Africa, and they found that if they crushed seashells and mixed it with water, it would actually become this sticky adhesive that could glue small rocks together. So they started to notice this when they saw conglomerate rocks, and they thought maybe we can actually find what is making these rocks glue together, and they discovered cement. And with that, they built the most amazing structures. So you can see there in the bottom right this amazing Roman aqueduct. This is in Bologna in Italy. There's thousands of these aqueducts all over Europe. They are absolutely amazing. And the incredible thing is that was built over 2,000 years ago, but look at it, it's standing as if it was new. Meanwhile, we're building houses in Kurdistan that barely last 20 years. The other thing they were able to use this cement for was they could build a road network. So before the Romans came along, you have to realize that usually most people never traveled more than maybe 10 miles from where they were born. Traveling was just hard. There were just footpaths or goat tracks between place to place. There was no real road network. So suddenly Europe began to trade with one another. Towns and city-states could trade because they had this road network, and the prosperity and the education and economy of all of the Roman Empire flourished because of this road network. Now, the reason that cement was so good is that it has a very high compressive strength. Look at that aqueduct there on the bottom right. There is no way you could build an aqueduct like that out of wood or even straw or aggregate, because it just doesn't have the right compressive strength properties, but they were able to do that, the Romans. But yeah, as I said earlier, materials are chosen on two principles. Is the material available in the location? And compatibility. Are the properties of the material suitable for the task? So, that photo in the bottom left, that's from the capital city of Yemen. That house, that was actually my house. I lived in Yemen, in Sana'a, for 6 months, and I lived in that house. It's about 700 years old, the house, and it's beautiful. It's made from clay oven brick. Why did they not use stone? Well, because it's a sand desert. It's just not available. They can't use masonry stone in Sana'a, so they had to make clay oven bricks. Now, look at that picture from Wiltshire, England in the middle. This is actually my late aunt's house. I used to have summer holidays in this house when I lived in England. They do have stone available there, and so they've built the walls out of stone. However, why have they built the roof out of grass? Well, you can't build the roof out of stone because it would just be far too heavy. The roof would collapse. one of the properties for the roof needs to be that it will be light. And so grass is available in Wiltshire, England, and so they've made a grass roof. It's what we call a thatched roof. And that house there is about 500, 600 years old too. So both those houses are about the same age. Now, Amara, Iraq. This is a bit of an older photo. This photo is actually from the 1990s. Now, what was in Amara in the 1990s? Well, it was actually a swampland. I don't know if you've ever heard of the Marsh Arabs, or I think in Arabic it's Arab al-Ahwal. This was the largest wetland in the world. The only way you could move around is from boat. And people used to build islands by flattening grass reeds, and then they would build their houses on these muddy islands, and they were the Marsh Arabs. Now, one of the properties of the material to build a house like that is that it needs to be really light, because it's on a very soft and weak foundation. So grass or bulrushes from the lakes and the wetland were plentifully available, and they were able to build houses out of it because the property of it was that it was very light, which is something that they needed for these houses. And I understand that even now around Amara, you do have some people still living in these grass houses at times, but not nearly as many as there once were. During the 1990s, Saddam Hussein persecuted the Marsh Arabs, similar to the Kurds, and he actually drained the wetland, and that way he was able to destroy the environment and their homeland at the same time. So, material properties can be split into three different categories: physical, mechanical, and chemical. So physical properties are basically materials that determine the physics, the properties that determine the physics of the material. So density, that's how heavy it is for a given volume. The void content, are there little avenues inside the material that water or air can get into? Porosity, that means can it react with water? Moisture content, does water live inside it? Permeability, that's similar to void content. Is it waterproof or can water get through it? The crystal structure is related to all of that. Mechanical properties, you're looking at strength. So shear, flexural, tensile, compressive strength, torsion strength is another. Also stress, which is basically all about how the material can stretch when under force. And also hardness, how easy it is to scratch the material. Chemical properties would have to do with whether the material is rust resistant, whether it can insulate or conduct electricity or heat. Does it react with acid? Is it carcinogenic? Does it cause cancer? Many of you may have heard of asbestos. It was a material that was used from the 1950s to the 1980s. It was a very good insulating material, and generally houses from that era were a lot warmer because of the insulation and cooler in the summer. However, a big issue with it was it caused cancer. So that's illegal now. You can't use asbestos. Thermal expansion, does the material get bigger or change shape when it gets hot? Its color, does it reflect? Is it transparent? Can you see through it? That's a very important property if you're building a window, let's say. And then material selection. So material science is basically just looking at the properties of materials. Material engineering takes it a step further. You look at the properties and you say, hey, what properties do we need for this component of the civil engineering project? What properties must the roof material have for that house, or the cable for the bridge? And from that, you can then select a material for a given house. So this is just a typical example of how you go about choosing material. What are the materials available? Is it strong enough? Is it durable enough? Is it serviceable enough? That means, can you maintain it? Is it cost effective? Diamonds are very strong, but I'm not going to be building my house foundation out of diamonds because it's too expensive. Is it environmentally friendly? That's becoming a bigger consideration in civil engineering all the time, and then you can select the material. If at any point the answer is no for any of these questions, we stop what we're doing and we look at another material. So that's the end of this lecture. Your homework, do your assignment. Assignment 1 is based off the historical overview of building materials. Now, you can talk to me about this lecture in the Zoom tutorial, or if not, you can email me or you can call me. My phone number is on Moodle. But your assignment is due 10th of May. Please, please make sure you submit your assignment before the 10th of May. Thank you and goodbye.